Hi everyone, we're going to continue talking about similarity today. And just as a reminder from last time, we said that there were three different ways you could say that two triangles were similar. We had the angle-angle theorem, the side-angle-side theorem, and the side-side-side theorem. So these might come in handy today when we are asked to do something like in number 1, state two triangles similar to FEC. So I'll just read the first question. In the parallelogram ABCD, AB is 12 and AD is 8. DC is extended to F such that CF is 4 and AF is 20. AF intersects BC at E. Now in all of these questions, I'm never going to try to trick you. So if something doesn't make sense, please ask me what it is, but I think this question should make sense. So AB is 12. Since this is a parallelogram, DC is also 12. AD is 8, meaning BC is also 8. Then it says DC is extended to F such that CF equals 4 and AF equals 20. Okay. So we've labeled some lengths on our parallelogram with this extension piece. And the first thing is we're being asked to find two triangles similar to FEC. Now remember, this goes in terms of angles. FEC. And I think we can see one triangle that's similar immediately. Okay, and by one of our theorems, we know that if AD and BC are parallel, that means the angle at C is equal to the angle at D, and the angle at E is equal to the angle at A. So I can say that FEC is similar to FAD, and that would be by angle, angle. Let's find another one similar to FEC. This one might not be so easy, but actually we know that these two angles are the same. I believe the theorem is called OAT. You can take out handout 1 if you want to remind yourself, but I know that E and E are both the same on opposite sides. And then I can say also by the Z pattern that B and C, if I use the Z pattern, I can say that B and C are the same angle. So therefore, I know that E and E are going to line up. I know that B and C are the same angle, and that leaves that F and A are the same. Sorry, AEB. And this is again by angle, angle. Okay, any questions with this, we can go over them on Monday, but I think this should be okay. So what that means is I can use these now, proportions for B. So what I can say is if I want to find the lengths of BE and AE, there are a few ways I can do this. What I've recommended to you is I said that anytime you have similar triangles that are sort of overlapping, you might want to rewrite them as separate triangles. So first, let's look at BE and let's call it X. So what I'm going to do is I'm going to call this distance X, okay, from B to E. We're going to call that X. And what that means is the remaining, or EC, that's going to be 8 minus X. So now what I'm going to do, and I always want to line these up so that they're equal angles, are lined up. So we said that FEC is similar to AEB, right? So I'm just using this similarity statement to draw out and reorient my triangles. Now let's label what we know. So we know that CF is 4. We know that EC is 8 minus X. We know that AB is 12. And we know that EB is X. So I actually didn't even need to write this down. As long as I write down my proportion statement. So I know that EC over EB is equal to CF over BA. What I'm trying to say is this side over this side is equal to this side over this side. All right, let's fill it in with numbers. 8 minus X over EB equals CF over AB. Now we cross multiply. 12 times 8 is 80 plus 16, that's 96. That is 6. All right, so we know that in the big picture, we know that BE is actually 6, meaning EC is 8. So BE equals 6. That's all I'm being asked for, actually. So how do I find AE? Well, it's a very similar process. Okay, so I know that AE, let's call it Y. So if AE is Y, then EF, this distance is going to be 20 minus Y. Okay, and again, we don't have to write as much, but we can say 20 minus Y over Y equals 4 over 12. Same proportion as before. So I get 12, 20 minus Y equals 4Y, 240 minus 12Y equals 4Y, 240 equals 16Y. Y equals, I believe that's 15, but let me check. 15. So AE equals 15. All right. Okay, the next question is actually really important. We have to learn about the 30, 60, 90 triangle. Okay, what is a 30, 60, 90 triangle? Well, it is a special triangle, and I'll tell you why. So what we're going to do is we're going to start with an equilateral triangle, and I'm going to label it to each have a side length of 2. This will become clear. Why I'm labeling it 2 and not 1 will become clear in a moment. But what do we know about equilateral triangles? Well, we know that all the angles are 60 degrees. So here it says, cut an equilateral triangle in half and prove that any triangle with angles 30, 60, 90 has sides in proportion of 1 to root 3 to 2. And that is in order. So this is what the question is asking us to do. So it's asking us to divide this triangle in half. Okay. And then there are a few things we know here. So we know that this angle is 90. We know that this angle is 60. And because of our sum theorem, we know these angles have to sum to 180. This smaller angle is 30 degrees. Now, I also know 2 cuts, or 2 side lengths from after the cut. So I know I've cut the base in half, so that base, the new base is 1, and the hypotenuse is 2. Now, I said hypotenuse meaning this is a right triangle, meaning we can use Pythagorean theorem. So what I'm going to do to find, and let's call this h as in the height, h squared plus 1 squared equals 2 squared, h squared equals 3, so I did some quick math there, which means that h is root 3. Okay, so when I solve this triangle, okay, 30, 60, 90, I know that the base length is 1, the hypotenuse is 2, and the height is root 3. Now, something that we talked briefly about last time is that every triangle that is similar to this triangle has the same shape but a different size. So what that means, what that shape means, is if I were to use a scaling factor, and let's call the scaling factor A. So if I were to literally take this thing and make it bigger or smaller, all the sides would get bigger or smaller by the same proportion. So technically, okay, anytime I have a 30, 60, 90 triangle, okay, we can write it in either one of these two ways. I can scale each of these by A and get the new side lengths. Okay, but what that means, basically the whole point of this is if I write this down in order, 30, 60, 90, the side length opposite the 30-degree angle has length A. The side length across the 60-degree angle has length root 3A. And the side length across the 90-degree angle has length 2A. And then you just pick your A, and the rest falls into place. Okay. I should mention here that this is actually like root 3 times A. So the A is not underneath the square root there, just for clarity. Okay, one point I wanted to make, this happens quite often in math where you want to find the area of an equilateral triangle. Now I'm going to label it in a way that you'd more likely see it on like a test or a contest. So let's call each of these side lengths X. Okay, so if I call each of those side lengths X, if I want to find the height of this triangle, okay, the equilateral triangle, I know that this base here is going to be x over 2, or half of the base of the equilateral. And I know that this, by proportions, because it's a similar figure, this is going to be root 3 over 2x. How did I get that? Well, basically, this is a this triangle has a scaling factor of 1/2. Okay, so I take all of the side lengths of this triangle and divide by 2. So what that means is the base of this triangle is x. The height of this triangle is root 3 over 2 times x. So if I put this in the area formula, I'm going to get base times height divided by 2. Okay, so in this case, it's root 3 x squared divided by 4. So if you look this up online, this is the area of an equilateral triangle where x equals the side length of the triangle. Okay, I just thought it's worth mentioning here. Okay, let's move on. So we've got a case here where we have an equilateral triangle ABC where all the side lengths are 6, and we draw two of the medians. Now, if you remember back in analytic geometry, a median is from a point to the midpoint of the opposite side. Okay, so midpoint is important. So two medians, AM, so A goes from here to the midpoint of CB, and BN goes from here to the midpoint of AC. The two medians intersect at G, connect M and N, so you don't have to do that, I did that for you. On the figure, find 3 pairs of similar triangles. So I'm going to pick my first triangle to be triangle ABC, okay? And I can see that because M and N are midpoints of are midpoints of CB and AC respectively, okay, I know whatever this is, my side lengths have been cut in, whatever length this is, my side lengths have been cut in half. So I actually do know the side lengths. So my original triangle ABC has side length 6. In my second triangle NMC, is going to be, we've got a ratio of 6 to 3, which equals 2 to 1. Okay, and I got this by side, 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 or angle, angle proportionality. We can think of it either way. Okay, what's another set of similar triangles? Well, I can see that triangle A, B, G is similar to triangle M, N, G. Okay, so this triangle here is similar to this triangle here. Okay, and this is actually, I mean, we have several possibilities here, but I'd put this under by angle, angle theorem because we use the Z pattern a couple times. We know that these two lines are parallel. Okay, so what is the ratio? Well, all I need to do is compare one proportional side. So I can tell that my NM and my AB sides are proportional, okay, which means that this has to have a proportional of ABG has side length 6, MNG has side length 3. So again, this is a 2 to 1 ratio. Next, I want to do a 30, 60, 90 similarity. So I'm going to pick triangle AMB, and I'm going to find a triangle similar to that. But before I do that, I want to show you how to use similarity to solve for the sides of this triangle. So I know that this is a 30, 60, 90 triangle, okay, because AM is a median of an equilateral triangle. So I know I have 30, 60, 90 here. Now, I know this base is 3 and AB is 6, and I could use Pythagorean theorem here to solve for AM, but what I'd rather do is draw a similar shape to, or use similar figures with my 30, 60, 90 special triangle. Now, I've lined this up, okay, and I know that the lengths of a 30, 60, 90 triangle are in proportional 1 to 2 to root 3. So what I can do is if I want, I can call this, I don't know, H, and I can say H over root 3 equals, so H over root 3 equals 3 over 1. And then I can see that H equals 3 root 3 by cross multiplication. So instead of doing Pythagorean theorem now, I can see that I can calculate for the side lengths of my triangle. So actually, I just did part B. We just solved for AM. Okay, so let's just say we jumped ahead. But what I want to do is compare this triangle to another 30, 60, 90 triangle, and I'm going to use this one here. Now, how do I know this is a 30, 60, 90 triangle? Well, I know it's a 30, 60, 90 triangle because NB is also a median. Okay, so if it's also a median, that means that this is 60 and this is 30 here. So if I just look at, if I just look at GMB, I know this length is 3, I know this is 60, I know this is, I know that's 30, then this length has to be 60. And again, I can use my 30, 60, 90 triangle, so it's 1, 2, root 3, and I can compare the side lengths here. And here I should be drawing in, so all these side lengths are associated to angles, right? So across from the 30-degree angle, there goes my proportion 1. Across from my 90-degree angle, I have proportion 2. And across from my 60, I have proportion 3. I'm actually going to move this over here. Maybe make it a bit smaller. Okay, so if I want to solve for side length, let's call it y, the hypotenuse, and x will be the other side. What I can do is compare it to my similar triangle. So x over 1 equals 3 over root 3. Now, sure, x equals 3 over root 3, but we said we never liked a radical in the denominator. So I'm going to do this thing, we call it rationalizing the denominator, where I'm multiplying by 1, but I'm writing 1 as root 3 over root 3. So we end up getting 3 root 3 over 3, and then the 3's cancel out. So I get that my x is root 3. And similarly, I'm going to get y over 2 equals 3 over root 3. I'm going to get y equals 6 over root 3. I'm going to multiply the top and bottom by root 3, and I'm going to get y equals 2 root 3. So lo and behold, in the end, my triangle MBG has side lengths 3 to root 3 and root 3, and that is in the ratio of 1 to 2 to root 3. Now, finally, similarity statement. So I'm going to compare triangle AMB, which is 30, 90, 60 in that order, to this triangle here. So I know my 30-degree angle is B, triangle B. My 90-degree is M, and my 60-degree is G. So AMB is similar to BMG. Looks good. Okay, to what ratio? So I'm just going to have to take one set of sides that's proportional. So let's look at AM and BM. So AM we said is right here is 3 root 3. Okay, so this is how I find the proportions. I take the scaling factor of one set of proportional sides. So BMG, if we're looking at BM, that's 3. And then we can reduce this. This is actually with the ratio of root 3 over 1. So apologies, this got a bit messier than I had anticipated. But basically, we did B. We did part A, and then we actually did find AM. NM is actually 3, and I think we mentioned it earlier, okay, because NM is just an equilateral triangle similar to ABC with a scaling factor reduced in half. So 6 divided by 2 is 3 there. And then we have the last thing, which I'm just going to write here. What is AG? Well, I can see that AG is actually AM subtract GM. So what did we get for AM? We got that, I should probably have written so. AM, this is AM here. AM is 3 root 3. Okay, and then GM is right here. That's root 3, which is 2 root 3. Okay, that one. Okay, so that was a lot of work for one question and probably not enough room. But I think you get the point of how to use 30, 60, 90 triangles. Now I think we did a good job there. Okay, I'm actually going to skip C and D. We'll talk about this when I'm back in person. But I do want to do number 4 with you because number 4 is actually kind of deceivingly, well, it's not deceiving. Guys answer part A really with a really short answer, and I want to say that the answer to number A is not obvious. Okay, what do I mean by that? In triangle ABC with A equal to 90, B equals 30, and okay, we have our 30, 60, 90 in there already. We draw the altitude. What's an altitude? Well, it's perpendicular to the opposite side, right? So AH, that's a 90-degree angle. Okay, 90-degree angle there. And median AM. What does median mean? Well, it cuts something in half. So I know that CM and MB have to be the same length. Okay. I also know that HM is 2. Okay. Why is HAM 30 degrees? It's not completely obvious. Okay, so what do I mean by that? Well, I can't just go right out and say that I know. So I do know that CHA, based on the information I know, I can tell you that that is the 30, 60, 90 triangle for sure. Okay, but I can't really say anything about AM uh, uh, creating a 30-degree angle with HAM. Okay, so what do I have to do? Well, right now, what I can do is take the hint and say that if I create a rectangle, okay, by extending AM out like this, okay, this isn't perfect, but by an equal distance, I obtain a rectangle. So what I'm doing here is I'm saying that AM and this distance is equal. And because this is a rectangle, we know the diagonals are the same length. So I know that CB equals, let's call this A, I don't know, N. So I know that the diagonals of this rectangle are equal, which means that, okay, all of these are equal. And if that's true, then this angle has to be 30 degrees, which means HAM is also 30 degrees, okay? So that's how I know that angle HAM equals 30 degrees, okay? So that's part A. I'm not going to do all this writing, but I think I've explained it with my words. Okay, so for part B, we have to find a bunch of stuff, okay? And we can do this because we can see that all of these now are 30, 60, 90 triangles. Okay, so if I want to find, for example, AH, okay, what I'm going to do is take, we're going to put A up here, H down here, that's what I'm looking for, we can call it X. Okay, and I'm going to use the triangle that has a side length that I know. I know that side length is 2. Okay, so now I can compare this to our trusted 1, 2, root 3 triangle. So I know that this is 30, this is 60, and in my special triangle, 30, 60, 90, the one opposite 30 is 1, the hypotenuse is always 2, and this is root 3. So I can say that x over root 3 equals 2 over 1, or x equals 2 root 3, which therefore means AH equals 2 root 3. Okay, let's look at the next one. So we got AH. What's AM? Okay, well AM, we can do the same way. Y over 2 equals 2 over 1, so y equals 4. So AM equals 4. All right, how about AB? What we can do is look at ABM 30, 30, and I know that AM, which I just found, is 4. And look what I can do. I can create another 30, 60, 90 triangle, okay, and compare it to this one, 30, 60, 90, 1, 2, root 3. So if I just want this distance from here to here, let's call it M. So I have 4 over 2 equals M over root 3. Okay, so I'm going to get M equal, oh, that was weird. That was even weirder. Okay, I'm going to get M equals 2 root 3. But that means that AB equals 4 root 3. Because it's twice as long. All right, so we got AB. How about AC? Okay, I can see that AC equals AM because triangle ACM is equilateral. How did I get that? Well, I believe I have 60, 60, 60 as my angles, right? Looks more like this. Right, I've got ACM, 60, 60, 60. So all of these are going to be 4. So AC equals 4. And how about BC? Well, BC is going to be 2 times AC because we said AM was the midpoint of BC. So BC equals. Alrighty. We've got one more to do. This one's a little bit misleading, I guess, because we just did a whole whack of 30, 60, 90 questions, and then I give you another question, and guys just somehow assume that this is 30, 60, 90, but in fact it isn't. Okay, so we have to be careful that unless it says that it's 30, 60, 90, we can't assume it is. So here we go. We've got a right triangle ABC, and I know that A is 90. I know that AB, which is the shorter length, is 6. Maybe we can make this look a little bit shorter. Is 6. Okay, and AC is 8. And AH, again, here we go, is the altitude of the triangle. That is, AH is perpendicular to BC, so don't put it in the middle. Okay, it has to be perpendicular to BC. Okay, and the point H is situated. Okay, so AH is the altitude that I just drew. Okay, now find 2 pairs of similar figures on the triangles on this figure, and I'm going to do one better. We're going to find 3. Okay, so I know this is not a 30, 60, 90 triangle, and I know because one side is 6 and the other side is 8, so already it's not in proportional of 1 to root 3. Okay, but what I can see is that A, B, and C, okay, if I name these angles, I don't know, theta and alpha, we know that theta plus alpha equals 90 degrees, right? Okay, so now if I go back to my original triangle, and I can see that this is 90, and this is theta. So in this triangle, okay, if I have to associate, or if I have to label this angle, what will it be? Well, because theta and alpha add to 90, I know that this angle has to be alpha, okay? And then if I view this angle here, well, I know that alpha and theta add to 90, so this has to be alpha as well, which makes sense because this is 90 at H. So I can see now that I have 3 triangles actually, all having a 90-degree angle, and all having my other 2 angles equal to alpha and theta. I'm going to move this. Okay, so if I look at my medium triangle, and I line it up so that theta's on top and alpha's at the side, okay, what I get is H, A, C. So these are similar, and I've lined them up so the sides are proportional. Okay, again, and I have this other smaller one, alpha, theta. So I've got H, B, A. So these are all proportional. So I can write them down as triangle ABC is similar to triangle HAC, which is similar to triangle HBA. All right, so I found 3 actually, but that's okay because it'll be helpful. Using these similar triangles, find AH, so let's label this. AH, let's call that X. BH, let's call that Y. And CH, let's call that Z. Okay? And what do we know? Well, the whole entire thing is a 6, 8, and if I use Pythagorean theorem, I'll get that BC is 10. Or I can notice this is actually 3, 4, 5 triangles scaled up by a factor of 2. Okay? But now what I can do is use what I know, so I can actually continue. So I know that AC is, what did we say, 8, and I know that AB is 6. So now I have enough information to solve this problem. So what I'm going to do to solve for Z, I'm going to associate the 8 and the Z, and the 10 and the 8. So I get 8 over Z equals 10 over 8. So 64 equals 10Z. Z equals 6.4. So this is actually an accurate answer because I didn't do any rounding. So this is technically an exact answer. So CH equals 6.4. All right, and similarly, we're going to solve the rest of the triangle. 8 over X equals 10 over 6. Okay, AH, BH, and CH, so we still have BH, okay? So I've got 6 over Y equals 10 over 6. So BH equals 3.6. Okay, and lastly, it says find again AH, this time expressing the area of the triangle ABC in 2 different ways. Okay, this is a good one. Okay, I am going to copy and paste this triangle. Okay, and I'm going to get rid of some of this stuff. Okay, so what do we know about this triangle? Okay, if I just look at it this way, I can see that the area is base times height divided by 2. So I know that the area is 48 divided by 2. I know the area is 24, right? So what if I want to figure out the height this way? Well, if I take this and copy it and paste it, and then I just, oh, can I not? Oh, I know what I did. I actually want to paste it as an image. So now what I can do is I can change what I think is the base and what is the height. Okay, so I know that this distance is 10, okay, because that's a hypotenuse. But the area is still base times height over 2. The area is still 24, right? It doesn't change when I turn it on its side. So 24 equals 10 times, and in this case, this is going to be the height over 2. So I get 48 equals 10h, or h equals 4.8. So all that's saying is find the altitude a different way. Okay, using area. So find again AH, this time expressing the area of the triangle in 2 different ways. Okay guys, we're going to end there. I'm going to do number 6 with you when I'm back at school.